Thank you, Jan. Good morning, and thank you for coming. I'm very happy to be here. My name is Jessica Kerr, better known as Jessitron, and I'm excited to talk about velocity and acceleration and how do we get better at our job? Because that's why we're here, right? It's at least our excuse for coming to the conference. Along the way, I'll try to answer such compelling and enduring questions about software development, like what is done? Which programming language is the best? And the one that's really personal to me, why is this so hard? Because I have been developing for 18 years, and it has not gotten easier. It gets harder all the time. And I'm like, is it me? Am I getting old? I turned 40 this year. But I don't think it's me. I think there is something about our work that is inherently hard, that if we're doing it well, it's actually harder than if we weren't. So let's start by defining velocity and acceleration. I only got my bachelor's in physics, but I remember this stuff really well. So here's a graph of happiness over time, that as we invest time into our software, we hope that it gets better. And every manager loves this graph because it's nice and smooth, and most importantly, it goes up and to the right. Everyone loves graphs that go up and to the right. Of course, everything about this graph is bullshit, but we'll get to that in a minute. Now, the velocity is the rate of change. So it's the slope of the line. And here, it's a constant slope, and it's about 1. So here's our d happy dt, and that's supposed to be a flat line, but close enough. Our velocity is a constant. Acceleration is change in velocity, so the acceleration here is 0. Very unsatisfying for us, but our managers would love it if this was a thing, because then they could plan. Unfortunately, what software development really looks like, it's more like this. It starts off going okay, and then it gets slower, and then, oops, broke production. And then it's just really rough, right? It's unpredictable. And then sometime we stop developing features, and you would think that the value would stay constant, but we know better than that. The world around the software changes. The meaning of value changes. The systems we interact with change, and the libraries that we have installed get security patches. And eventually, there's other software out there that's much better than this, but we can't use that, oh no, because this was a capital investment, and you will darn well use the software that was developed for your use if it's internal. And at some point, because nobody can change it, it's not alive, but it's still running, and it's making people's lives worse, it becomes zombie software. More on the zombies later. But first, let's question more of this graph. Next, the x-axis. Why do we measure software effort in terms of time? Because it's easy, that's why. But it takes a lot more than time to move software forward. I mean, personally, the time I sit at my desk correlates very loosely with how much better the software gets. Because, there's time in the shower that I'm thinking about it, or like when I'm writing in my notebook over breakfast, that's moving it forward, and there's plenty of times at my desk where I'm like, woo, and the software is just sitting there just fine. So time isn't sufficient. We need something more. So there's a word, creplets. Creplets are units of time and attention. But time is not enough. We need focused attention on the software in order to change it, in order to add value. And often of a day, I run out of attention before I run out of time, especially if I'm pairing, and so I'm very focused for a long time. After about 6 hours, I need to go answer some email or something because I'm done with this code thing. My brain is fried. So we need more than time. We also need attention. And it's attention with a brain with specific knowledge, which we'll get to later. The other thing about velocity to consider is that it's not just one. It's a vector, and a vector has magnitude and direction. So this picture is Professor Bieniek from where I went to college, and he used to dress up in this vector man suit in order to get through to the engineering physics majors that vectors have magnitude and direction. They have to go somewhere. So in our little chart here, really at each point, the velocity is a vector, its magnitude is 1, and its direction is up. Increase in value. What does that even mean? Velocity has to have a direction, and I'm sorry, but better is not a direction. So where are we going? That is the crucial question, because software is like real estate. You can build a gorgeous mansion, but if it is in the middle of the desert, wrong tool, you are not going to get a good return on it. In real estate, it's location, location, location. In software, it is it useful? Is it useful? No, but really, is it useful? That is the real eternal question, because the hard part is building the right software. So what is the right software? And that is why acceleration is particularly valuable, because we need to change more than the magnitude of how fast we're going. Even more crucial than that, we need to be able to change direction. And acceleration is required to change the direction of the velocity. I think of it as we have a vision, we have a quest. At Atomist, it is to change the way software development is done by bringing some automations that are currently too difficult, by bringing those in reach so that we can work at a higher level and write more code to make our own work easier. Okay, so to get there, we need to navigate through a sea of everything we could possibly build. And here's us. We're down here in, come here, give me the tool. We're down here in this little boat. Here's a boat. And we need to get to that star. So we point in that direction, but we do not sail out into the open sea with a Gantt chart that goes 150 years into the future. No, we don't. We look for safe harbors. We look for places to stop and land and take our bearings. And these are supposed to be little snow-capped mountains, see? So with our boat, we'll navigate to the nearest one. What's the smallest thing that we could build and stop and get feedback? So we sail our boat to the safe harbor, which is deploy to production. And then we talk to the customers and we get our bearings and we see if the star is still in the same place, and we decide on the next safe harbor to get to. And in the meantime, while we're trying to get there, we get some sea monsters that jump up and attack us, and we've got to fight them off. And sometimes we're delayed by a couple days defeating them, and other times we're like, that harbor, it doesn't look so good after all. How about that one over there? And this is fine too. We learned something, and we shifted direction. That's essential. But these monsters, they feel sometimes I feel offended by them. Travis, why is your API documented so poorly? And why does some REST calls require auth and others won't work if you do send it auth? But I've come to realize that these problems are, in fact, they're not in the way of me doing my job. They are my job. This is what I'm here to solve. Jesse Watson, in a really good blog post about the hard thing about software development, calls this the field of micro-problems. It's all the problems that are between us and the solution we're trying to produce, all the problems that are in that area between the business and the technology as we try to navigate this area and produce the system that will solve our business problems. There's the system. As we navigate this field, we find all these micro problems, and we need to be able to solve them. And to do that, we have to be pretty darn good at the business and the technology. And when we give an estimate, there's a dirty word, we think we understand the business and the technology, and we know some stuff about it, but we never understand it enough. We never know where all of the monsters are, because maybe you worked in Java for 10 years and you think you're good, but have you called exactly that method out in these libraries? Have you used this particular API before? And oh gosh, did you even know the garbage collector could do that? There's always something new to discover in the technology, but even more in the business, because the business has probably been around for longer. And the business is made of people. And you can describe the happy path easily enough. And that happy path may be 99% of code executions, but it is 1% of the code. Because every error path is different. And you'll find all kinds of alternate ways to get to the top. And you'll learn about all the different little dead ends that people could go down and how can we redirect this. And there's always way more to it than you think when you start entering these instructions into the computer. Only when we try to get to this level of detail do we discover how detailed we really have to be. Yesterday in the 360 developer track, Martin Thompson brought this up. Design until you feel you understand the problem, code until you realize you don't. Repeat. That is totally how it goes. There is nothing, and I really seriously mean nothing in the world that gets you to understand every detail of the problem like instructing a computer how to do it. Okay, so yeah, that does sound hard. How do we get better at our job? I'd like to zoom in on the we. Who is it, or what is it, that is producing value for our customers, our users? It's not just the software alone, and it's not just us. Clearly, we are involved. Clearly, the software is a part of it. And so is all of the little interstitial code around the software, the deployment, the queues between the services, and maybe we've got some Kubernetes going on here and some surroundings. All of this stuff together with the people who are maintaining it form a system. I used to call it the socio-technical system, and that's also true. That is accurate. However, there's a point to bring out in here that this is a system of mutual learning. The code learns when we change it, we teach it new tricks, and we learn from the code, from its output. It can tell us whether it was useful by whether the customers are using it. We learn from the exceptions it throws to us, that the world is not as we would prefer it. And together, we each get better over time. And this is a living system of mutual learning. The word for that, by Nora Bateson, is symathesy. Sim for together, mathesy meaning learning. And when you look at it like this, as a dynamic system that is continually learning, you start to see why our job is so interesting. And you can kind of embrace maintaining the relationships between us and the code, and us and each other, and the code and the other code. Can we all be nice to each other? Part of this is our mental model of the software. In order to change the software, we have to have the mental model of how it works, of what the different parts do, what the different names mean, that kind of thing. And only with that can we change the software. That mental model can be really hard to build. You would think that if someone has created a system, you could read it and figure it out and understand how it works more easily than you could write it again from scratch. But as far as mental effort goes, you would be wrong. Valentino Breitenberg has a gorgeous little book called Vehicles. It's about this big, and it's from the 60s, and it's a thought experiment about tiny little cars, little vehicles, that start out with one motor and a sensor, so like the more light it sees, the faster it goes. And then we'll add 2 motors and 2 sensors. And so if it sees more light, it goes faster, but then one wheel goes faster and it runs away from the light. Or you switch them, and then it runs toward the light. And then you add thresholds, and it starts running toward the light and then running away. It's really simple underneath, and as you go step by step and build it up, there's nothing, it just doesn't seem complicated to you. But if you look at it from the outside, it looks like these vehicles have behavior. This book is so fascinating. I swear by page 25, I said, I understand religion now. But the thesis is this law of downhill invention, uphill analysis, that creating a complex system from scratch and understanding how it works is easier than coming to a system from the outside and figuring out how it works. And this is a big deal. It means that if in your team or your organization you have some not invented here syndrome, those people are mentally lazy. Because it may feel productive, it may be more work, and it certainly takes more time to rewrite something from scratch for yourself than to understand what other people have already written and solved all those micro problems. It is mentally easier to create it. I mean, yeah, you put in more time, but it really is harder to understand that system and more productive. So yeah, next time you're tempted, this is way too complicated. I'm just going to write it myself. Well, maybe it's complicated for reasons you don't know until you get in there. And yeah, just accept that you're not stupid. It really is hard to figure out someone else's system. And that has implications. To understand the system, and we talked about knowing the tech and the business in order to create the system, but understanding the system is crucial. You have to have that mental model in order to change it, and that mental model is really hard to get if you don't have it. So this means we have a special relationship when we do have a mental model of the code. If you wrote the system, then you are in the privileged position of having a mental model without having to do that uphill analysis. And it's really hard to pass that on to someone else because you don't know what you know. There's these like unknown knowns in there. Because it wasn't that hard for you. It is simple for you because you built it up from scratch in small pieces, and it is not simple for other people. And if you can't explain it to them and bring them up, or if you, more likely, you're changing it so fast that they can't catch and they can't get there, then you look like the 10x developer. But really, it's just that they haven't done that uphill analysis yet. It's really hard. So we have a relationship with our code. If you wrote it, you're its parent, you brought it into the world, you know what all those scars are, you know what all those weird little mispronunciations and those cute little intra-family words, you understand those, you're good. If you adopt a piece of code and form that mental model and build that relationship, awesome. That is extra challenging, and it's what most of us do. And it's one of the things that makes our job so hard. But that's super powerful. And you've got to like figure out what it's doing while interacting it, while influencing it without knowing all that history. Super hard. This means we have a relationship with our code. I think of like the evolution of a system as kind of like when we first write something, it's a baby. Maybe it's a script that only runs on my computer. Maybe it's a little website with no error handling. And that's fine, because often the baby, it's easy to write, and we can use it to answer the question, is it useful? But then whenever it fails, whenever it craps out, we have to change its diaper by hand. But if it's useful, if it looks useful, then we invest in potty training. And then it gets to be a kid. And maybe we deploy it as a service somewhere in Cloud Foundry. And that's cool. But then as soon as it hits the real world, we start hitting real error cases and all those corners that we're like, I didn't know that could happen. And it starts to be a teenager. I mean, only real world exposure can like grow from a piece of software from kid to teenager and on toward adulthood. And now we need security, we need authorization and all that stuff. And if we get it far enough so that it can take care of its own shit, then it becomes an adult. And the adult has monitoring and alerting and stuff, but really it's got like, it restarts itself if it fails, and it's only the unexpected problems that it needs to call you on. Now, if at any point you stop development, and the team moves on, and no one has a mental model of that software anymore, it's expired, or they've left the company, and no one can change it, then it's the zombie. So that can happen at any stage. It's a zombie, and it will eat your face. So let's not talk about zombies anymore. That's it for the zombies. Yesterday, Martin Thompson said that he doesn't like the word software maintenance because it doesn't really describe what we do. I mean, maintenance used to be like you squirt some grease in the joints and do other mechanical things that just needed the same thing needed done year after year. And that is not what we do. We do something different every day. So I don't think maintenance is the right word. So I propose software parenting. Because it's different every time, and it often surprises you. And here's an example. Last week, a couple of weeks ago at Atomist, we decided, let's try putting a GraphQL endpoint in front of our Neo4j database. Will that be useful? Okay. So I wrote some scripts. I downloaded the GraphQL extension for Neo4j, and I loaded it up in our staging database. And I wrote some scripts to make the schemas and update it and that kind of thing. And so, sure, we have a GraphQL extension on our Neo4j now. But it's totally baby mode, because whenever we need to update the schema, I do that. I mean, yeah, I made READMEs, but nobody else has their environment set up for it. And so they just call me. And this has proven useful, and it is way time to mature it past the baby phase. It is well worth potty training, because if something happens with that schema now, they're screwed for the rest of the day. So yeah, right after this conference, I intend to raise this up to a baby and put some more automation and clear documentation around how to do that. The extension itself, come back, please. The extension is written by Neo4j people, and it's in the kid-teenager phase. I'd say early teens, because we're one of the first people, I guess, to use it in production. And we find things that aren't implemented. We found a few bugs, but mostly just stuff that they'd never implemented because nobody had ever needed it before, because it hasn't had a lot of contact with the real world. Fortunately, at Neo4j, they're like super happy to get our issues and bug reports, and I'm working from the tip of master here, and that's fine. And they want to mature this, and they know the only way to mature it is to get those bug reports from the real world. So they're all super happy and fix them really quick, and then we keep going. And this is how we help each other grow up. If this is my creplets for the day, these are all my creplets in this jar, and I still have all this software in baby stage, I've got this GraphQL stuff in baby stage, then that means that's overhead. Because anything you have to do to just keep things going in the state that they are, the classic meaning of maintenance, is overhead. And anything like outside the semaphosy too, so if I'm like sending status reports outward, that feels like overhead. And you got to get that done before you can make forward progress and add value to the software. And then hopefully you can take a little bit of time to work on acceleration, which usually consists of reducing the overhead, because if there's like a production incident, or I got to take my kid to the dentist, the overhead is still there. And productivity or value output can drop to pretty much zero. And then I don't have any time to reduce the overhead, so I can't get any faster. I can't get out of this hole, and that's really bad. So that's what we want to avoid, and that's why we want to grow our software up. This gives us a way to answer what is done, because we're parenting this software. I mean, when are you done parenting? Only if your children die, so I hope that doesn't happen to any of us. But in software, I totally hope it does. Done is out of production. If you can determine that something is not useful and take it out and remove the feature, then no one will ever call you and ask you about it again. It'll be great. That is the definition of done for software. It's out of production. Other than that, it's always there. Oh, the other thing you can do is leave the company. I get so much done, like the first 6 months at a job, But after that, your context, your knowledge, your mental model starts to become the most valuable thing. Because you have, and that makes you the recipient of a lot of questions, and that's excellent, but it does make you busy. Another way that doing it well makes it harder. Okay, so if we do want to raise our software all the way to adulthood so that it doesn't bother us, so that we can continue to support more software and we can add to our children and have another one, it takes a lot of work. So here are some of the things, just a few of the things that move us along on the software maturity scale. And I measure this scale from a shell script that runs on my machine to Netflix. And Netflix has like some serious adulting going on. But adults are hugely more expensive to build than teenagers. And most software is not sufficiently useful to ever need that, but that's okay. The point is that we can move it along according to its usefulness. And I want to emphasize a few things on here. Versions, testing, and deployment, these are particularly crucial, and they're crucial early as well, because this is how we enable change. And our job is not to write software, our job is to change software. Once you've written a line, especially once it's in production, you're not writing it, you're changing it. And that's way harder. So when we do get software to adult, that's awesome, because it calls us when it needs us and not otherwise. And if you'll notice, some of these are a few characteristics of adulthood. A lot of these aren't in the software itself. Backwards compatibility might be, or you might have a proxy outside of it that's faking it. Out-of-date libraries might be inside, but we could build software from the outside to take care of this. It doesn't have to be in our business software. It's in all that code around the code. All this blue stuff here and a bunch more that isn't pictured. So the code around the code, by adding some of that, we can grow our software. It doesn't necessarily mean change in the business services themselves. It can be infrastructure, and it can be the little pieces of code that are between us and the code, the deployment scripts, CI and CD, the automated tests and continuous deployments, and all of these things make the whole semaphosy more adult. And those are automations. So let's talk about automation. And in particular, I want to talk about local automation, local to your team. So stuff that you run, or ideally stuff that you share with your team and your whole team runs. There's a special property here that software can be kids. Even though it's advancing the business software toward adulthood, the local automations that we write can be kids, which are orders of magnitude, thousands and hundreds of thousands times easier to write and to change. So for a local automation, I've got 5 whys, a what, and a how much. First why, saves time. I mean, this is the absolute minimum obvious reason to automate something. How many times do I do it, times how long does it take? Compare that to how long it would take to automate it. So if I spin up a new project twice a year, and it takes me a week every time, but it would take 3 weeks to automate it, it's going to take a long time to get my return on my investment. Except it's not. First of all, we save more than time. We save creplets. Oh, I misspelled it there. We save creplets, and so we save attention. Maybe it's something smaller. It's not as big as writing a project. Maybe it's every time I need to make a pull request from a commit, it's like 4 commands in Git, and then I have to go to GitHub and click a thing. I can and have built a little script that does those 4 commands and then opens the web page on GitHub. It's a tiny thing, but I'm quicker to make PRs because of it. It changes my behavior. I don't wait as long to make a pull request as I otherwise would, because it's 2 letters, PR, blah, 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 instead of requiring my more attention than that. Now, if you get bigger, say you have this project, say you write the new project automation, and then that year you create 8 new projects. Well, why? Well, because it's easy now. And so those other 6 projects are ones that you would not otherwise have created. You would have just glommed them onto some existing service because that was easier, that was safer, and that was the way to bring value to your customers. But it's a negative architecturally. It's better to have these things in their own service where they can have their own scalability considerations and read-write trade-offs, and where they can more easily be deleted if they're not useful. Architecturally, it's better, but it would have cost more. Now, if spinning up a new project takes half an hour because you automated it, suddenly the incentives are different, and so our behavior is different. We've eliminated a trade-off, and so we're going to spin up a new project exactly when it's appropriate to spin up a new project, and we've changed our world by changing our behavior, by changing our incentives through automation. My favorite example, personally, is Git. Git totally changed how I work. I mean, you can use it as a faster subversion, but then I was like, oh, I can make a commit before I go to lunch, and I don't have to share it with the rest of the team, even if the build is broken. Sweet, now I can save my work, and I can come back later and tell the story, and I can get access to that story instantaneously because the log is right there. Totally changes the way I develop, and I never want to develop without it. I call these particular automations shaving the golden yak, which is another talk. And those are quite rare. But when you find one, it makes a big difference. Okay, next why, safety. And I don't mean like human safety, like I died or I stubbed my toe. Safety from disasters of all sizes, including bugs, including frustration, including embarrassment. Oh crap, I broke the build again. Automation provides this because every time we do trip over ourselves, then we can go back into the code, because this is local to our team, so we have full ability to change it, and we add a little check, and then we're safe from that. It tells me, I don't think you really meant to do that to prod, and I'm like, oh, you're right, I didn't, thanks. Reproducibility is another one. Now we can, how do you do a deployment? Like this. Exactly like this every time, because the only real documentation is code. Peter Hilton has a name for this, or one way to achieve this, RDD, README-driven development. It's called, how do I do this? Oh, I'll write the README for it. And you start writing the README, and you're like, oh, God, I need to cover this case. I'm just going to write the code. Because often it's easier to express something in Bash than in Markdown. And then it's documented, it's automated, it's useful. You don't have to explain it to anybody. You don't have to explain it to the new team member. They can dig in the code and read it when they need it, and before that, they can deploy. Here's a different concept. And this is a little more abstract, and it's not really about us, it's about the managers. Legibility is a word from the book Seeing Like a State by James C. Scott. And this is a book about politics, forestry, city planning, but it totally applies to code. The concept of legibility is an understanding that is descriptive at a low level and also at a high level. So like in the Middle Ages, towns didn't have like street names and people just had nicknames. They didn't have like family names or anything. They didn't need it because everybody knew everybody. Everybody knew where everything was and nobody else cared. And then you get like governments coming in and they want to tax all these people. So in order to tax them, you've got to count them and you've got to say who owns what land. And so they brought people with big books and they made everybody take 2 names and have an address. And I mean, we find that useful now, but back then they didn't. But it was about the government, because once you can say, once you can list the people, then you can count the people, and then you can add the counts from different cities, and this forms a monoid. And then the understanding can roll up by region and country, and you can see things like, oh, is my country growing or am I losing population? Is it shifting from here to here? Are my tax revenues commensurate with the prosperity of my nation? That kind of thing. So we need this in programming. Decision makers above us really do need to understand what's going on and whether we've encountered more or fewer monsters than expected. That is essential. Welcome to Jira. Lord knows Jira is not for us, because we hate task managers because our tasks are different every single time. So they never work, but they are important. It really is important to get people the information of what's going on. And that's an important thing. So if we automate things, if we automate what we do, like task switching or deployment, merging of PRs, whoever writes those automations has the power to introduce reporting to whatever system management wants, whether it's Jira or somebody's spreadsheet, that can all be automated. So automation has the power of giving legibility in ways that don't burden the people doing the work. And in fact, the automations can make your life easier, and so you're happy to use them, and the legibility just happens, and everyone's happy. Speaking of everyone's happy, this one's even better. I got this word out of the Journal of Organizational Psychology. Generativity is the difference between the team's output with me versus without me, as opposed to personal productivity, which is the code I personally delivered. So if I'm coding along on something and you come and ask me a question, because I wrote the system, so I have a better mental model of it than you, and you come and ask me the question and I say, I'm busy. Okay, I'm being productive, but I am not generative. Whereas if I get an error message and I'm like, God, that was really hard to figure out, I'm going to go change the error so that the next person who hits this does not have the same problem, that's generative. It's a distraction from what I'm supposed to be doing, but it smooths the team's work forever. And the whole team. So if you're the person who encourages people, who asks how they're doing, who answers all the questions, you're going to get less work done personally. But you are generative, and you are the most valuable. So generativity is about your contribution to the team's output, not just yours. And automation is extremely generative because it takes your knowledge and makes the road easier for everyone. So what are we going to automate? This is a decision to make. And when I was thinking about this, I spent a couple days on a task. I was making automations for cascading tests. And I mapped out the task in this particular case so that I could study what is it that really holds me back? What is it that I'm doing? So each line to the right here represents a context switch of subtasks or micro problems, and the red ones are really angry. And then I can go back and I can look at that and say, well, what would automation really help with? What do I do often? It turns out that I very often have to upgrade this library that I use and bring myself up to the latest standards because it changes really fast. If I could automate that, that would be really helpful. What do we wait for? If I'm waiting for builds often, can I automate the thing that I need to do after the build? Because that would be great. Then it doesn't take my attention. Or at least I could asynchronize this and have it ping me in Slack when the build is done so that I can get to it then and not have to watch it. And what surprises us? What do we trip over? This is an emoji that I use in Slack, the wait emoji, when I want to complain about something that dragged me down by tripping over it. So if I'm coding along and I'm testing, I hit a not implemented exception, I love those. They tell me exactly what isn't implemented and exactly what I need to change. But if I get a null pointer exception in a long string of this, dot, that, dot, 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 it could be any of those. So when I'm in the baby stage, the error handling that I do introduce is the kind that's going to surprise me negatively. At home, if I walk across the living room and there's a toy in the middle of the floor and it's like a teddy bear, I'm like, maybe I'll pick it up later. Somebody might play with it before then. But if it's a Lego car, I'm like, oh my gosh, I do not want to step on that. So I pick it up right away. So the things that are nasty surprises, any sort of automation or just coding practice that can help us with that is important. And the last question is a tough one. How much time do we spend on automating? Because while we're working on acceleration is a multiplier for moving forward, but that only helps if we're also moving forward. If we're not spending time on moving forward because we're doing all our own automation, what are we doing? The answer is time box it. Just like any other software, the burning question is it useful? And so that time box grows proportionally with how you're useful. It absolutely, definitely is. So the first time I wish I had a PR script, I don't do anything. And the second time I wish I had a PR script, I probably still don't do anything. But the third time I'll spend 15 minutes on it. And if that's not enough, then the fourth or fifth time I'll give it an hour. And then maybe I'll consult with my teammates, and they'll all be like, oh my gosh, I wish I had that. Okay, now maybe it's worth spending a day automating TS lint or whatever it is. Okay, so this is also really good practice at making your effort proportional to how useful you know it is, because you get to determine usefulness here. The goal being to spend fewer couplets over time on overhead, more on actual work, and whatever we can do for acceleration, because this takes our whole semathesy into adulthood. All right, so how do we get better at our job? Our job is doing things we've never done before. Every day is different. Every day is something new. So how do we get better at that? Transfer of learning is taking something you've learned in one context and using it in another context. So this is what we need. We need to use our learning in one place to learn faster somewhere else. And I do not recommend this book. I read it so you don't have to. It's expensive and it's not that good. But it does have some useful information in it. So here are some of the things that help us transfer our learning. We need at least these 5 things. So expertise, and in particular, I want to zoom in on expertise and get a little more detailed with it. We need in-depth expertise in something. So go deep on Java or Go or whatever it is that you want to be really good at, or software in general, because we transfer learning through metaphors, and this gives us something to relate everything to. Personally, I relate everything to software. Software is a complex system, so it works for everything. I think of biology in terms of software analogies. I think of human relationships in terms of software analogies, and this is helpful. That knowledge also needs to be filled in. You need to have edges and limits. You need a lot of success cases and a lot of failure cases in your past. And then you need some breadth. Like, the more things you know, my grandmother used to say, know a little bit about everything, just enough to have a conversation about it, because then you get more conversations. And also, you get kind of a framework to hang new knowledge on if you just know a little bit in breadth. So that's useful too. The next thing is mood. And in particular, the mood while you're learning something to make that thing available for transfer. It helps to be happy. It helps to be interested, to feel interest. And it helps to have a practical aim, because that also gives you a framework to hang your knowledge on so you can retain it better and use it more later. So the next time you need to deal with Nginx configuration, and you go and you Google it, and you copy something out of Stack Overflow, yes, do that, but also take a little extra time to fill in some edges and learn some vocabulary of Nginx configuration, and just fill it out a little bit. Oh, the next time you have a business question, and you were like, okay, I think I need to ask them about this particular error path, go a little deeper. Find out the history. That's where the real why is, and that's really where you'll get depth and understanding of the business. Reflective practice, yeah, you've got to do it and think about it. How could I have done better? I really like it when I have a pair, and at the end of the day or the pairing session, we say, okay, how did that go? What would we do better next time? That's where you get better at something. Theoretical knowledge, yes, learn your data structures and your algorithms and your design principles, because again, that gives you a framework to hang things off of. And culture of transfer, I'll talk about in a minute. I want to get to levels of transfer. So near transfer would be like, I learned something at school, I used it at work. That's great, and this is totally useful. Far transfer is when you take an idea from one context and use it in a very different context. So near transfer is like getting work done. If you go a little farther and you're like, I haven't seen this before, but you know, that other thing is a little bit like it, maybe that has some relevance, then you're problem solving. And if you go farther than that, it's called creativity. This is where we get new ideas, from taking ideas from one place and putting them in another. The mind space for this is very different. So for work, you want to be in closed mode. And closed mode means you have a single mental model that you're working with, you have made a decision about where you're going, and you're going there, and this is about moving forward, which is great. Whereas for problem solving and creativity, you want to be in an open mode where you can shift between mental models. Humor is really good for this because that's the secret of a joke. You think you're in one reference frame and you're in another. I would tell a joke, but I'm terrible. All right, so the good thing about closed mode is this is where we move forward. This is where we have velocity and we're adding value. And that's where we want to spend most of our time, but we often get surprises. Now, tests are really helpful here, and like the REPL, because you can do constant experiments. You can verify your hypothesis very quickly. I think this will work, yep. I think this will work, yep. And then when it doesn't, you're still in a closed context. You don't have to move very far. You can adjust your model and get back to it. Whereas when you have no idea how that exception happened or nothing changed, why is this broken now, you need to ask open questions. You can't go in with a hypothesis. You've got to be open-ended and say, wow, what could have happened here? What don't I know about the system? So switching back and forth between those is painful and costs us a lot of time. I talked about micro problems. Every time we write a line of code, we're making decisions, usually several decisions. What do we name this? Do we do a null check? In that case, what do we do? A lot of these decisions are business related. A lot of them don't feel business related, but are, such as the null checks. And this is my attempt to draw a fractal of these decisions of, okay, how do I break down this problem? Now, how do I break down that? Now, what do I do in this case? Our job is not writing code. That's the easy part. It is making decisions. Lots and lots of decisions, which require expertise in the tech and the business. And this is what Jesse Watson argues in his post. This is why development is not a commodity, and you can't just outsource it, because you have to have that context to make these constant decisions. So in order to get better at programming, I do not want to write fewer lines of code. Our industry seems like it's obsessed with, can we express more in fewer lines of code? Well, you know what? The expression is the easy part. That is the downhill invention. I do care about how easy it is to read, but as I'm going, what I really want to do is to make fewer and easier decisions. Because my creplets of attention are really, I want to spend them wisely. So how can I make fewer and easier decisions? Well, automation is one. That pull request is not 4 things I have to think about. It's one now, and automation takes a lot of decisions out of it. I particularly want to give a shout out to code formatters and linters with autofix. I freaking hate linters without autofix, but autofix is fine. I do not care how many spaces or tabs or whatever. I don't care the formatting of my brackets or what line they're on. I just don't want to make that decision. So please, those of you who care about it, have fun, write a program, I will run it, or I will have my automation run it, and my code will look consistent. There is value in consistency. I just don't want to make those decisions. That is not where I want to put my creplets. Pay for software. And if you ever get to the point where you're like, oh, you know, WordPress and this plugin, it doesn't do it quite the way I want. I think I'll write it for myself. You know what? Maybe the way you want causes problems down the line, and they're doing you a service, and there's a reason they did it the other way. And even if they didn't, you know, spend the time to understand the abstractions that people have created. This is so good. Totally, you're not just getting code, you're getting those decisions made for you of what matters, what is worth thinking about. And then expertise. Expertise makes for easier and better decisions. And in particular, expertise in the business and in the system, which means I don't want to spend as much time on the technology. You know, the technology is the part that anybody can learn. Nobody else can learn this business or this system without being there. And that brings us to what is the best programming language. So these are a bunch of programming languages that I've either used at work or spoken about at conferences. So I have some breadth here, and I've decided the best one is definitely whichever one you already know. Because I can learn a new programming language in a few weeks, no big deal. But I can learn the build tools, the ecosystem around it, the package management, the versioning, the libraries, the major frameworks, the memory management and performance considerations, the idioms, and the community in decades. So yes, language matters. And I used to be all very polyglot, woo! And now I'm like, God, can I just use one language? Please, can I just get good at something again? Because I want to have that depth in the technology, but I don't want to spend my time on that because your serious value to a company as a developer is in your knowledge of the business and the system. That's what smooths us out and lets us make these decisions. Call out to tests makes decisions way easier. Will this work? I don't know, try it. That is hugely powerful because our job is not just making it work, that's the easy part. I feel like it works. I saw it work once. Can you show that it works in all the conditions that we need it to? And can you show that it still works after more is added? This is so much harder. And you should have more test code than real code, and it should take longer. And that's okay, because showing that it works is way harder than making it work, but it's incredibly valuable because it gives us freedom to change. All those other factors of adulthood can come if you have the freedom to change the software. Also helps to have observability, so you can see what's going on in production and roll back, so that you can back out your decision if you made a poor one. That makes it easier to experiment. And the much neglected outcome metrics, which would tell you, is it useful? Can I kill it? So we're not system builders. We are system movers. And that is much harder. And it's much more powerful because we can improve the system as we're in it. The whole Symathesy is our system, and we are constantly moving it through our interactions with people, our changes to the code, and everything we build around the code. This is the system that we are moving toward greater usefulness, which is constantly in a different direction. The people in the system are important too, and I haven't talked about them much, but I do want to get back to culture of transfer. In order to transfer our learning in open mode, being creative or problem solving, we need to be around, it helps to be around other people, but only if none of them make us feel defensive. That asshole is holding everyone back from learning and from using their learning. No wonder they look productive, they're keeping everyone else down. So we want to say yes and. We also want to encourage impossible ideas. John Cleese calls these the intermediate impossibles. Wouldn't it be awesome if this library deployed itself to all the production services? Oh yeah, what if we could git clone every repository and make a pull request, and if the build passed, just merge it? Oh hey, I heard about a tool that does that. We're working on that now. So you can get to the next idea. You can do a farther transfer than you would individually with some impossible ideas in the middle. So yes, our work is hard. It has all these contradictions. We have to be detailed and creative at the same time, low level, and keep that broad perspective. A lot of people have said that growth is a series of I'm not who I thought I was. So maybe our job isn't what we think it was. Maybe we can get better at it. Maybe I'm not being productive. Maybe I'm not writing code. Maybe that's not core to my job. I'm doing it, but maybe it's not about making it work or building systems. Maybe it's about being generative. It's about decision making, showing that it works, and moving systems. Richard Campbell has a beautiful quote. Follow your dreams? Fuck your dreams. Try stuff and see what makes you happy. It's the same with software. It is okay to have a vision, a quest that we won't reach in my lifetime, or in this project, or in this sprint. That's fine. That's fine. We're going to move forward one safe harbor at a time. Automate your oars. Keep your heads up for navigation. I'm Jessitron, and I'm a system mover.